everyone, my name is Joseph Williams and this is our demo video for our SmartLock project. So here we have the GitHub repository I created for the lock client, and because the lock client is the most complicated part of this project, that's what I'm going to be focusing on for this demo. And so this is just a README for the project, and it kind of goes over the technology stack and how to set the project up if you choose to install it yourself, and some of the main hardware that I purchased when I was putting it together. So that's the information that's included in the README, and then also a list of references that I use when I was doing research for the project and then when I was actually building it. Okay, so first let's take a look at the client.js code and then compare the implementation, compare our project implementation with the actual requirements from the coursework. So the first requirement was that the SmartLock should be able to register itself to the gateway and send heartbeats and operation logs to the gateway. So if you take a look at the code, this section is where the SmartLock client is connecting to the broker, and so that fulfills the registration requirement. And then for the heartbeats, this is how I implemented the heartbeats. And basically what happens is this function is called every 30 seconds, and each time it's called, the current state of the system is published to all the subscribers. So that's how the heartbeats are sent, and that's how the subscribers are notified of the heartbeats. And then so that's how the heartbeats work. And then finally, for the operation logs, the way persistence is implemented in this project is using a database. So when commands come in, a new entry is created in that database table, and this is the function that's called to do that. And then when an authorized user sends a request to get the logs, that triggers a call to the publish log function, and that function pulls a list of recent commands from the database and then publishes that to the users that subscribe to the SmartLock. And then so that's how we fulfilled requirement number one. And then for requirement number two, the system should lock and unlock given the correct password. So this is the function that receives messages, and receives messages from the mobile or desktop clients that are controlling the lock. So when a message is received, the password fields are checked, and if the passwords are valid, then if the command is either lock or unlock, then that triggers a call to the control door function, and this function, based on the current state of the system, either transitions to a new state or sends an error message. So for instance, if the system is in state 1 and a lock command is received, that triggers the lock function, and this along with the unlock function, these are the functions that actually write to the servo and change the position so that the physical deadbolt actually moves from the unlock to lock position. And so that's how we fulfill the requirements for number two and handle lock and unlock requests to the SmartLock. And then for number three, we're supposed to be able to activate and deactivate the temporary passwords. And so for activation, the main user can request a temporary password with this get temp command, and when they do, that calls this temporary password generation function that creates a random password and then returns it to the returns it in response to the request, and then that password can be used. That password can be given to a temporary user, and then that temporary user can either submit a lock or unlock command that triggers that same control door function. And once that command is used, the temporary password is set to false, so it can no longer be used. And so that's how we implemented password activation and deactivation, and automatically disabling the password after it's used. And then for number 4, we're supposed to send notifications if someone breaks the lock. So these are the 4 system states. The top 3 states are good states because they can occur during normal operations. These are things you expect to happen. And then the final state is an error state, and in this state the door is locked, but somehow the door is open. So if the system is in this state, that means that the lock is in some kind of broken state, or the door is in some kind of compromised state. And so the system is in an error state, and the subscribers need to be notified. And the way this is handled is, this is the function that listens to changes in the door sensor, and if the system transitions to that error state, it triggers a call to the publish alert message function. And this function, let's see, yeah, so this function captures the current date and time, and then lets the subscribers know that something is wrong. So it publishes it, to emphasize it even more, it publishes it on the danger topic, and that's how the notifications for an error state or a broken state are handled by this system. And then finally, we're supposed to return operation logs and error messages. So for this, I just set up 3 main responses: success and error for normal states, and then for that error state, there's a danger response if there's some kind of system failure. And so for success and error, you can take a look at that same control door function, and when a response successfully updates the state, the response is set to success, and then if the request is invalid, it's set to error, and that response message is then sent to the subscribers, so they know the results of the latest command that was submitted to the SmartLock. So that's an overview of how the code works and how it fulfills the major requirements of the project. So now let's take a look at some of the physical hardware implementation details. Okay, so this is what I use to brace the motor against the door. I don't have a 3D printer, so I kind of had to improvise, and then this is the motor and the adapter I created to actually turn the deadbolt, and then this is what the system looks like when everything is connected. So you have the door sensor, you have the Raspberry Pi, and you have the actual hardware that locks and unlocks the door. And then when everything is mounted, this is what it looks like. You'll notice that the sensor has been replaced with a different magnet, and this is just because I needed a magnet that fit the door frame better, but it functions the same way. It still functions as a switch when the door is either open or closed. And so yeah, this is what the system looks like when it's mounted, and this is how the lock is connecting to this is how the motor is connecting to the deadbolt. And this is just what the lock looks like when nothing's mounted to it. And then And then finally, let's take a look at what happens when commands are actually submitted. So this is a free MQTT client, and I'm publishing to the command topic, and I'm submitting the password and the unlock command. And so yeah, so this is how the unlock functionality looks like on a real system, and then this is the lock equivalent of the same thing. So that's what it looks like when the door is locked. Okay, and then finally, I just want to run through the results of some commands when a desktop client is used. So first, let's connect to the lock client. So we'll get that started, and then once the lock client starts up, it can receive commands. So the lock client is started, and now here's the MQTT Explorer application that allows messages to be sent from the desktop. So if you request, let's do get state first. So if you send a get state request, then it returns the current state of the system, and then if you send a lock request, the system is moved to the lock position. You get a 200 success, and the door state won't update until, or the system state updates once the heartbeat is triggered. So this will automatically update after the 30 seconds has elapsed. And then you can also send an unlock command, and then I'll demonstrate the temporary password. So let's see. So this is how the temporary password is requested, and then this is the temporary password that was generated by the lock client. And so we could do we can implement the temporary password with a, since the lock is in the unlock state, we can send a lock command, and as you can see, there's a success when the temporary password is used. And if you try to unlock the door at this point, you get an unauthorized message because the temporary password was automatically expired. And then finally, let's take a look at, let's go back to the main password and take a look at the logs. And so the response contains information about the message history. So a list of 10 recent commands that were sent to the system is summarized and returned from the database. Anyway, with that, that concludes the demo for our SmartLock functionality. Thank you.